Welcome to video 5.6c, another proof showing that a quadrilateral is a parallelogram. So here's example 2. Given the triangle CAR is isosceles with base CR, so right away I know that's congruent to that, and I will be able to show that's congruent to that, just based on isosceles. Also, AC is congruent to BK. Oh, okay, looks like I'll have some transitive action going on. Angle C is congruent to angle K. Looks like I'll have some transitive going on. Show that bark is a parallelogram. It's kind of fun when the letters spell a word. So I want to prove that this is a parallelogram. Okay. So once again, there's those 5 theorems to prove that a quadrilateral is a parallelogram. Let's come up with a game plan. There's definitely no triangles to show congruent here, so I'm thinking of something else. I definitely will be able to, I can see it already, to get these opposite sides congruent. I don't really think I'll have much of a chance there, so maybe I'm then thinking getting them to also be parallel. Ooh, if I got this angle and this angle congruent, then these two lines must be parallel because these angles are corresponding. If you don't see it, I could extend these lines a little bit. So those would be the lines I'm trying to get parallel. This could be the transversal right here. And hopefully you can see that this angle here and this angle here are corresponding. They're both above the transversal and to the left of the parallel line. Okay, so now my game plan is finished. I'm going to get one pair of opposite sides to be both parallel and congruent. So I'll just mark that down. One pair, opposite sides, parallel and congruent. So now that I have the end game in mind, now I'm going to do the proof. Okay, so I'll just pretty much do what I've already done marking it up. So I'll start with the sides first. So I'll say triangle CAR is isosceles with base CR. That was given. Based on that, I'll get these, I'll get these sides right here. So AC is congruent to AR. If isosceles, then two congruent sides. Okay, I was given these two sides, no, I wasn't. I was given AC to BK. AC is congruent to BK. That was given. So now, just to show you how my proof will flow, if AR goes to AC, and if AC goes to BK, that's the transitive property. I can then say AR is congruent to BK. So AR is congruent to BK, transitive. And again, I'll put a little thing here. So that's opposite sides congruent right there. Now we've got to work on those sides also being parallel. So what I'll do is I'll go to the angles. That's going to be my way of doing it. So from this isosceles triangle over here, I can also get angle C to be congruent to, I can't call it R because there's angle confusion, so I've got to go ARC. And that would be if isosceles, then two congruent angles. Okay, then I'm going to use this over here. Angle C is congruent to angle K. That was given. And again, I'm going to use the transitive. If arc goes to C, And if C goes to K, then arc goes to K. Angle ARC congruent to angle K by transitive. Then, again, once I've got those angles there to be congruent, then I've got these lines parallel. So I'll now say AR is parallel to BK. We'll say if corresponding angles congruent, then parallel. I'll star that. That's the parallel part. So now based on those two very important steps, I'm going to get my answer. So arc is a parallelogram if one pair of opposite sides of quadrilateral, both parallel and congruent, then, gosh darn it, we're a parallelogram. Whew, that was another tough one. So there you have it. Another proof showing that a quadrilateral is a parallelogram.